They plan was to knock me out the top of the game, but I overstand they truth is all lame. I hold cannons that shoot balls of flame right in they fat mouth, then I carve my name.
Okay, here's number 2. We're asked to sketch a graph of each of the following transformations of our 2 to the x graph. Okay, so this one here, f of x is equal to 2 to the x minus 2. So here what's going on is that we have this x minus 2, so the minus 2 is attached directly to the x, right? So that means we're going to have some kind of horizontal shifting going on. So horizontal shift. And this is kind of opposite since it's horizontal, so that means we're going to be going to the right 2, okay? So here's our original x versus y, so this is 1, 2, 3, 4, 1, 2, and 1, 2. So normally what we would have is a graph that looks like this for our normal 2 to the x, right? But now what we're going to do is shift each of these points to the right 2. So let's just do that really quickly here. So we have 1, 2, this one point, that point shifts there. This one goes over 2, goes right there. And this one goes over 2 and comes right here. So now if we connect those, we get our new graph. Okay? And that one right here on the right-hand side, that's going to be our answer to 2 to the x minus 2. Okay? So this one right there, that's going to be our graph. Okay, so now let's move on to h of x. This is equal to 2 to the x plus 3. So we see that we have a plus 3 added on, and it's completely separate. It's not directly attached to the x. It's kind of just being tacked on to the end. So that means we have a vertical shifting. Okay, and this one is a direct change, so this means up by 3. So now we're going to take our normal 2 to the x, okay, and we're going to shift everything up by 3. So let's go ahead and do that here. 1, 2, 1, 2. Okay, so normally what we would have is something like this. I always like to draw the original like parent or toolkit graph first and then do the transformation. So if we move each of the points up 3, we get 1, 2, 3 here, and then 1, 2, 3 there, and then 1, 2, and 3 there. Okay, so then we have something like this, and we also see that our horizontal asymptote moved up by 3 as well. So now our horizontal asymptote is at y equals 3. Alrighty, number 3 says that starting with the graph of 4 to the x, find a formula for the function that results from, and we have 3 different kinds of transformations we could do. Okay, so the first one is shifting f of x, which is this 4 to the x, 4 units upwards. So if we want to move up 4, all we have to do is take our original function, which is 4 to the x, and then just tack on whatever we need, so plus 4 in this case. And that's it. Vertical shifting is really nice. Okay, so now let's look at the next one. If we want to shift this 2 units to the left, and again we go back to our original f of x, so that's our 4 to the x. So 2 units left. So left 2 means that we have to attach something directly to the x itself, to the exponent, and we have to do the opposite. So if left 2 means like negative 2, we're going to subtract away that negative 2, so both of those become positive, and we get that our new formula is going to be 4 to the x plus 2, okay, where all of the x plus 2 is in the exponent. Alrighty, now the last one is just reflecting f of x about the x-axis. So if you reflect something, let's say this one, about the x-axis, we're really doing a vertical reflection, okay? So vertical reflection means that we have to have a negative sign in the front of our whole function, our whole entire function. So that means we just stick a negative sign in front there, not up here because that would mean a horizontal reflection, but we want a vertical reflection, so the negative sign just goes right out in front.
Oh, 56, nigga, shut the fuck up. Fuck that nigga, run that back. Money.
Run that back, man.
What?
I gotta get out, man. You gotta run that back.
Run it back? All right, run it back.